Welcome to the lecture for truth tables, the first one, lecture 8. What I'm going to do here is go over the concept of what truth tables are and how to set them up. It's a little bit involved in terms of the steps you need to do. It's another algorithm. If you remember, an algorithm is a recipe, but it's pretty straightforward once you get the hang of this. In fact, it's pretty mechanical and it's easy once you get past that initial hump of trying to figure out how to solve these things, how to set them up, and so forth. So I'll take you through the lecture of how to do that, and then I'll apply it in the homeworks. I'll work 2 of them from the homeworks, and then you'll notice that I have other video links for some of the other problems, and then you should also use, as always, the audio files and the picture files to try and hammer home how this stuff works rather than just copying down what I'm doing. Copying is an initial good first step, but to get inside of it, to get a sense and understand it for yourselves, you need to work some of this on your own, and the picture and audio files will most help you do that. So here we go. Truth tables and what are called tautologies. Tautologies is something you apply to truth tables. Don't worry about the terminology. Let's talk about truth tables first. You were briefly introduced to this notion in previous lectures, that it was that cross thing, like I have right here, and that's the truth table. And the way it works is you take some sentence, whatever it is, and you put it on the right side, and then the left side is the breakdown of the components of that sentence. So suppose we're given the sentence in this case that I just made it up, right? Any sentence whatsoever, but let's say that it's A or B and not parentheses A and C. The component pieces, if you look at it, just the capital letters, you list them in alphabetical order, so that's step 1. Set up the truth table, put your sentence down, and then put in alphabetical order the pieces. In this case, I have 3 pieces, capital A, B, C. The capital letters are important. The capital letters denote sentences. Lowercase letters, if you remember, denote constants. A for Albert, B for Bill, and so forth. But capital letters stand for sentences. So A might stand for it is raining. B stands for C's a tet. It could be anything, but they're usually atomic sentences, yeah? And then you're saying, here's the overall sentence. Okay, so moving on. This is about the only math you're going to get in the course. It's to determine the total number of combinations. We talked about this before, and now here it is. So to determine the total number of rows, the total number of possibilities to fill in on the left side of the truth table, the formula is 2 to the power of the number of pieces. So if there were 2 pieces, it'd be 2 to the second power, which is 2 times itself, 2 times, so 2 times 2. If it were 3 pieces, it'd be 2 to the third. That doesn't equal 2 times 3, which is 6. That's different. Exponents is you multiply it by itself that many times. So 2 to the third, in this case, we have 3 pieces, A, B, and C. So that fits this pattern, 2 to the third. It's 2 times 2 times 2 is 8. If there were 4 pieces, it'd be 2 times 2 times 2 times 2, which is 16. It gets big fast, okay? So after you determine that the total number of rows, in this case 2 to the third equals 8, there's 8 total combinations, and here's how you fill it in. You always start on the right side on the left side here, you start with the rightmost piece, okay? In this case C, remember it's in alphabetical order, and you do the one, let me use a dance type analogy, music analogy, right? You do the one step, oompa, 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 true, false, true, false, true, false. How many times? 8 times. True, false, true, false, true, false. I know it's ridiculous, but this works, trust me. So that's 8 times, and then you always, relative to what you just did, you double when you move over. So this is the 1 step, oompa, oompa. Then you do the 2 step. True, true, false, false, true, true, false, false. Like 2/4 time for those who had some music in high school. If you didn't, don't worry about it. 1, 2, ba, 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 okay? And then now you move over, and if this is 2, you double that, so it's 4. So this would be 4/4 time. That's like most songs that are out there. 1, 2, 3, 4, 2, 2, 3, 4. If you count off almost any pop song out there, you're going to find that that's the time signature it has. So this would be true, 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 false, 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 false. You know you've done your truth table right when on the right side it alternates 1, 1, 1, 1, 1, 1. And on the leftmost side it's half and half. Half trues and half falses, yeah? That mechanical procedure holds for any truth table whatsoever. We'll practice that more, but this is your first pass, okay? So keep that in mind. Let's move on. The next step, the next part of this algorithm, recipe, is the hard part. How do you apply all this stuff to the actual sentence you got? This is where the art comes in. And the basic idea is you start with your most embedded connectives, and then you work your way out to the overall main connective. You can think of this as sort of like chain of command. You can read all this in my lecture, but let me just go through this in words, okay? So chain of command says if you pass some information up, you don't go straight to the general, right? You start with the privates, and then you work your way up to the next level, and then you build on top of that, and then it goes all the way up to the top of the chain of command. So likewise here, you start with your most embedded connectives, that's like your ground level, and then from there you build up complexity to your higher level until you get to the overall sentence. The overall sentence is the main connective. That's why we emphasized main connected before, which is like the highest level of the chain of command. Okay, so let me apply that here. So if you look at the sentence, A or B and not parentheses A and C, what are your connectives? Well, you've got or, you've got and, you've got not, you've got and. What's the main connective? Remember, main connective is what's outside of parentheses or left over. What's outside of parentheses? You got two of them. You got the and the not. Suppose you don't know any better and you still don't have a feel for this, and you're saying, okay, you have a guess. It's either the and or the not is the main connective. Suppose you guess the not is the main connective. What does it apply to? It applies to the right side, what I have here highlighted. Well, what's in blue right there. Oops. Yeah, right there. That part right there is what the not applies to. That means there's something left over. That means it's not the main connective. The thing left over is the and. The and, what makes the main connective is it joins everything. It joins this whole thing on the left side right there and the whole thing on the right side right there. Okay? So that's the last thing you're going to do. That's the main connective. Where you have to start, what is most embedded is you start with the connectives that are most within parentheses. If there are no parentheses, we'll talk about that later. But in this case, there's two parentheses, there and there. So you can start with either the or the and. It doesn't matter. You can do either one. You're going to have to do both of them, quote unquote, first. Okay? If you look at the or, what does it join? It joins the A on the left and the B on the right. Here's your A and B column. These are the initial inputs. And now you have to remember the truth table for or. This is why we're building on what we did previously. Or, if you remember, is true when you have at least one side true. So I've got true, true. That makes it true. True, true. That makes it true. True, false. I have at least one side true. That makes the or true. True, false. That makes it true. False, true, true. False, true, true. False, false. Oh, there you go. I don't have at least one side true. I have false and false. So that makes the or here false. And likewise in the last case, false, false makes the last one false. Okay, so I did this or first. The other first thing I needed to do was the and. So I move over to the next one. The and, what does it join? It joins just the A and just the C. So I look on the left side at the capital A and the capital C, those columns. And when is and true? If you remember the truth table, and is only true when both sides are true. Any other combination makes it false, right? So true and true makes it true. True and false makes it false. True and true makes it true again. True and false makes it false. False, true, false, 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 false. False, true, false, and false, false makes it false. So there's the completed truth table for A and C. Now you work your way out. So you start with your most embedded connectives and work your way out. Think of it as like a neighborhood, a locale. The A or B on the left side, if you work your way out, it would be the and. The A and C, if you work your way out to the next connective, it's the not. Before you do the and, which is the main connective overall, you have to do the next, as it were, next level up or down, depending on how you're looking at it. So before I do the and, I've got to do the not. The not applies to the main connective inside the parentheses, because it applies to that whole thing within the parentheses. So the not applies to the and. And when you look at it, what you got to now remember, what does not do? Not flips around the value. So if and is true, the not makes it false. If and is false, not makes it true. If and is true, not makes it false, and so on and so forth. That's how you get this column right here, okay? This column right here. Okay, now we can finally move on to the main connective. The main connective, if you remember from the very beginning, is the and. And what does it join? The main connective on the left side and the main connective on the right side. What's the main connective on the left side? Well, it's A or B, that's your sentence, but what's the main connective of that sentence? It's the or. And on the right side, it's not parentheses A and C. What's the main connective there? The thing you just did. It's the not, the thing you just did. So when you look at and, it highlights the respective main connectives. That's like chain of command again. It's going one level down. You don't go down to the privates, the A and the B and the A and the C. You go down to whatever the next lowest level was. So that would be the OR on the left side and the NOT on the right side. And now you got to remember the truth table for and again. And is only true when both sides are true. So true and false makes it false. True and true makes it true. True and false makes it false. True and true makes it true, and so on and so forth. You guys can sort of do the rest, okay? So what I have here, box, that's your overall completed truth table for this whole sentence. That's what you're looking at. That's the thing you want at the end. Now, what you're going to be asked to do in the exercises is apply a definition. The definition is this thing called tautology. What does that mean? A tautology, here's the definition. You're going to need to know this for the midterm. If under the main connective the sentence is true all the way down, then it's a tautology. So let's look at this one right here. Under the main connective, is it true all the way down? No, there are a number of cases where it's false. That indicates it is not a tautology. Conceptually, what is a tautology? It's one way of talking about what's called a necessary truth, something that has to be true no matter what. The idea here is on the left side, you're exhausting all possible states of affairs. Let's use the example I used previously. Suppose you got 3 bets, Chicago, Atlanta, Boston, and Chicago, right? And this is tracking all the things that could happen. Remember, let's assume there's no ties. So when we're betting here, we're just saying winners or losers, no ties, right? And you've got all these various scenarios of what could occur. If you've got a sentence up above where no matter what occurs, it becomes true all the time, that's like saying it has to be true no matter what actually happens in the world. One application of this, for those of you who are betting fanatics, you go to Vegas. I mean, what did they say about Vegas? That you win? You might win from time to time. No, who wins on average? The house, right? How do they actually configure these odds? They're not just making them up as they go along. They've hired logicians and mathematicians in the back to sort of make sure that they've worked out the numbers so that on average Vegas will win, the house wins. It's pretty much guaranteed. The basis for this thing is something called a sure win bet, and its basis is actually in logic. This is something we study in another course, Phil 111, inductive logic, because Vegas has probability involved as well. But the background for this is something like this notion of a tautology, right? It's saying if you got these 3 bets, for example, and you're exhausting the space of possible things that can happen, if you formulate a statement in such a way, so up here I've got a sentence, right? But if you formulate a statement in such a way such that it comes out true no matter what, that's like what's called a sure win bet. No matter what happens, you're coming out ahead. And you can actually, the transference of this with some probability added in is what you get in Vegas, where you have certain edges, where even if someone wins people one night and some other people win big other nights, on average all that evens out and the house comes out ahead. There's a way to sort of calculate that. So that's one application of tautology. There's others in philosophy, but we don't need to talk about that. Okay, let's move on now to the homework. That's the end of the lecture portion. A lot of this is just practice. So for 4.2, there are 4 sub-problems. For the first one within 4.2, I already guide you through it here in words and then also in the audio file and picture files, and I have a video to guide you there. So you should check all that out. What I'm going to do here is move on to 4.2 number 2. I don't give you guidance there. Number 3, I don't have a video there as well, but you can use the picture file and the audio file. For number 4 within 4.2, I have not just a picture file, but I also give you the answer in case you get stuck. Okay, so let me do 4.2 number 2 to show you how this stuff works. 4.2, here it is in the book. Number 2. Remember, always read the instructions above. It'll guide you. So when you're in Boole, how do you set this stuff up? So let's go back to the lecture. You can look at it on your own if you want. You can follow along with my video. But the first part says you put in the sentence that you have. So 4.2 number 2 right here. Make sure you copy in the sentence exactly as it is. So I have parentheses. Remember, parentheses are really important. And then capital A. You type this in from your keyboard. Capital A, not lowercase a. That's why it's in red. Red means no good. So red, and remember, lowercase letters are constants. They stand for subword. Capital A, and so forth. Capital A stands for a sentence. Okay. Capital A and capital B, N parentheses, you got to do that, watch your parentheses, or parenthesis, whatever, capital A, and not capital B, N parentheses. Okay, so that's the first thing. You copy in the sentence as it is, exactly as is. Next, on the left side, you enter in your component pieces. How many component pieces do I have here? I have A and B and nothing else. Make sure you get all that. So I put in capital A, and then you see this plus button right here? That plus button gives you a column. It adds a separate column, and you want them in alphabetical order. So I should put the capital A here first, and then the capital B there second, in alphabetical order. Okay? And the next thing is, you got to remember the formula for the total number of rows. It's 2. Basically, think of each of these pieces as the number 2, and you just multiply it. So if there were 3 pieces, you think 2, 2, 2, 4 pieces, 2, 2, 2, 2, multiply. In this case, there's 2 pieces, 2 and 2, so 2 times 2 is 4. You then always start on the right side, and you fill it in from the keyboard. So TF, TF, Oompa, Loompa, right? And then you go over and you double what you just did. So if you did the 1 step there, now you're going to do the 2 step, you double it, true, true, false, false. I should say this, or maybe I shouldn't say it, because when I say it, people do it, so maybe it's better not to say it, but I'll say it anyway. Do not use these buttons up here that fill in the reference and build the reference columns for you. If you do that, it's going to be wrong. Grinder, it's going to be wrong. It'll tell you you can't do this, and it's up here in the instructions as well. And when you turn it into me, I'm not going to give you any credit, because all I can see is whether it's right or wrong. So make sure you construct all these things from scratch on your own by hand. It's good practice for you as well. Yeah? Okay, so you've done that now. Now it's time to fill in those values in the truth table. You first identify the main connective. What's the main connective? Or if you remember, main connective is what's outside of parentheses or left over. In this case, the or is the main connective. It's outside the parentheses, so that's the last thing you do. So the first thing you have to do is work with the most embedded connectives. What's most within parentheses? You've got this stuff on the left right there, and then you've got the other stuff on the right. It's your choice what you want to do first. Might as well go for the easier one. The left side looks easier, so let's do there. When I click under the AND here, that's the main connective on the left side, what does it join? It joins the A and the B. So when I click the AND, that's what it highlights, the A and B components. Before you click, you should try to ask yourself, what is it going to highlight? If you can anticipate what it's going to highlight, that means you're understanding. If you're just mechanically clicking and filling in, that means you're not quite understanding. And that's not going to help you out for the midterm, okay? So now you think, what's the truth table for AND? AND is only true when both sides are true. So true, true makes it true. You enter the T in from the keyboard. True, false, I don't have both sides true, so false. False, true, false, 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 false. Okay, move your way out or to your next most embedded, your next connective. Well, before I can do that, I have to do the other side because this was most embedded, right? So you might think, and here is what I got to do first. What does the and join? And on the right side it joins the A, and on the right side the not B. What's the main connective on the left side for the and? There isn't one. It's just A. What's the main connective on the right side? It's not, right? Not B. So when I click on the and, it's going to highlight the A on the left side here and the not on the right side. Before I can do the and, I've got to do the not because it's blank here. I haven't done that yet. Yeah? Remember, chain of command. So this is actually the bottom level. The not B is first. So I click on the not. What is it going to highlight? What does it apply to? Just the B. And sure enough, there it is, the B highlight. And what does not do? It flips the value. So if B is true, not makes it false. If B is false, not makes it true. If B is true, not makes it false. If B is false, not makes it true. Now you work your way out. Where's the next main connective? It's the and, the thing that we initially tried. What does the and join? What's on the left side? Just the A. And on the right side, what's the main connective? The not. Don't say not B. That's too much. You just did the not B. It's just the not. So when you click on the and, it'll highlight respective main connectives on the left and right side if there are any. On the left side there isn't one, so it's just A, and on the right side it's the not. So now you got to remember the truth table for AND. It's only true when both sides are true. True, false makes it false. True, true makes it true. False, false makes it false. And false, true makes it false. Okay, work your way out some more to the OR in the middle. That's your main connective overall. What does it highlight? Well, what's the main connective on the left side that I have in blue? It's the AND. What's the main connective on the right side that I have in blue now? So it'll also the AND. So it'll highlight the respective ANDs, the AND column and the AND column. And when is OR true? When at least one side is true. So here we go. True, false makes it true. False, true makes it true. false false makes it false, and false false makes it false. The last thing you're going to need to do is the assessment, like with 4.2.1. You click here on the assessment button, a thing pops up, and you only focus on this first one. Don't worry about the rest, just this first one for now. Is it a tautology? Well, remember the definition of tautology. It means under the main connective, it's T true all the way down. Is it true all the way down here? No, so it is not a tautology. Click on not, you click OK, you're good. And then the last thing you do is you click this button up here. This is the overall verify. If you get all green checks and green check there, you're good to go. And that means this is correct. So tautology means this sentence is not true no matter what. There are exceptions to it. Yeah. Now then you save it. You go to save as, just like with when we did this previously with other files. I've already covered this in 4.2.1, but let's do this here. You save it to your desktop, and then you always name it after the exercise. In this case, it's table for truth table 4.2, not 4.22. That would be 4.22, and then you're going to get it wrong when you turn into the grain grinder. But 4.2.2. Just like if you check out books from the library system, the Dewey Decimal System, the points are indicating further subdivisions. 4.2 and then 0.2. You save it, 4.2. You save it, and you're good to go. Okay? So that's that. The other one I want to work with you guys, you can take a look at 4.2.3 in the audio file and picture file, and then 4.2.4 also in the audio files and picture file. That'll help you out. I have video guidance for some of the rest. What I want to work with you now is 4.4 because it is the same kind of thing, but there is one slightly different thing concerning this notion of TT possible. You won't be tested on it on the midterm, but the exercise asks you about it anyway. So let's do that right now. So let's go to bool. Let's go to bool again. Okay, so here's 4.4, and you go through the same procedure as you did previously. You first copy in the sentence exactly as it is. So I have not, let's make this bold, not, parentheses, capital B, and not C, and not B, and parentheses. Okay, there's several things slightly different in this exercise. Well, first thing, this right here, B and not C and not B. They don't put further parentheses in there. This is a convention they adopt. Because only when all is true, only when all the pieces are true, it doesn't matter where you place the parentheses. If I tell you I'm going to the game and eating a hot dog and taking a nap, or I tell you I'm going to the game and I'm eating a hot dog and taking a nap, it doesn't matter what order I have it, whether the main connective is the first and or the second and, because they're all true anyway, right? So as a result, you can drop the parentheses. The same holds for or. Since or is true only when at least once, not only, but or is true with at least one side true, it doesn't matter what order you put the or in, what order you put your options in. So by convention, the book can drop the parentheses. For you guys, I will always put parentheses in the right place. So you notice here, if you click on this not, it says this is the main connective on the inside. It could have been that this is the main connective, but the bool just says since you got to choose one, it chooses that first. So that's effectively saying there is a parentheses there and there, which I'll put brackets. Brackets are the same as parentheses. If you remember, it just helps you to see. So it's effectively saying there's parentheses there. This is your main connective. Okay, now let's build your columns. How many pieces are there? 2. Put them in alphabetical order, so there's capital B and capital C. And then now how many total? 2 times 2, 4. So remember, don't ever use these buttons. You're in trouble. You're going to have to redo it from scratch if you do that. Start from the right side and fill it in manually. You do the one step, oompa, oompa, 4 times. And then you double it. True, true, false, false. Okay? Now you look at your sentence. What's the main connective? What's these? It's the not. These not. It's the not. The not's the main connective. That is the last thing you're going to do. So now if you look within what is most embedded, clearly it's parentheses, right? Clearly it's this thing right here, right? So you might say, oh, the and is the main connective on the within that this area right here. At the end where the main connective, what is it doing? It joins the B on the left and the not with C on the right. So when you click on AND, it'll highlight the B and the not. The not is blank. That means before you can do the AND, you got to do the not first. That's your ground level. So the not applies to, that's what it highlights, C. And that's what it highlights, C. And what does the not do? It flips the value. So true makes it false, false makes it true, true makes it false, false way out. Move your way out to the thing you just, the AND, the thing you just identified. And then the AND joins what on the left with B. And what on the right, what's the main connective? The not. The B, so that's what it highlights. The B column and the not column. AND is true only when both are true. So true, false makes it false. False, true makes it true. False, false makes it false. And false, true makes it false. Okay, work your way out some more. The next closest connected with this thing, these, right? You're working within the parentheses, right? It's the AND. So you might say, okay, so the AND next. What is the AND joint on the left side? What's the main connective? And then you just did the AND. And on the right side of this AND, what's the main connective? It's the not. So before you can do this AND, you have to do the attach not. The not attached to B. So when I click on the not here, that just highlights the B column, and that just flips it. So it'll be false, false, true, true. And now I can go back to that other connective. This connective right here in the middle. That part, what I have in blue, it highlights on the left side. What's that main connective for this in the brackets? The AND. What's the main connective on the right side? The not. On the right side highlights the AND and the not. And now you got to remember, when is AND true? Only when both are true. So false, false makes it false. So true, false makes it false. False, true makes it false. And false, false makes it false. Work your way out to the next connective. What's the only thing left? It's the not overall. Yeah, it's the overall main connective. Yeah. So what will it apply to? Well, what's the main connective inside? The main connective inside the parentheses. It's the thing you just did, the AND here. So when you highlight the AND here, it'll highlight the AND. And what does not do? It flips it. So true, 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 true. So this sentence is a tautology. It's something that, even though it doesn't look like it, it has to be true, like no matter what happens. Yeah, no matter what happens, like a sure win bet. Okay, here's the slightly different part from 4.2. You go to assessment. The first part's the same. Is it a tautology? Yes, because it's true all the way down. Okay, so you got that right here, true all the way down. But there's a further thing that the book is asking about, which again I'm not going to test you on. Tautology is something you might be tested on, but this other thing you know. So we're just doing it for the book's sake. TT possible. Is this TT possible? TT possible stands for truth table possible. What that means is it could be true. What does possibility mean? Okay, so for the moment, let's step back a little bit and I'll explain this. TT possible means it could happen. Let me use an example I always use in my classes to help explain this. So, ladies, it works better with the ladies than the guys. Who's the hottest actor out there, or hottest guy on the planet right now? I don't know. I can give me all kinds of names. I don't know. I got some strange ones in the past, like strange ones on David Hasselhoff. There's no accounting for taste, so there's no whatever. But oh yeah, Chris Hemsworth, whatever, the guy who plays Thor. So that gets some votes. So just play along. You can have your own private entertainment in your own mind, in your own private space, or what you want, whatever. So Chris Hemsworth, is it possible, I ask you, is it for you to have a date with Chris Hemsworth, the #1 guy in the world, right? And most of the people, they say, no, it's not possible. But careful, I didn't ask if it's probable, I asked if it's possible. The two are related, but the same possible means could it happen no matter how remote the chances are. Whereas probable means, is it probable for you to have a date with him? No, it's not, right? Because most of us, probability-wise, it's just not likely. But possible is different. Possible is, could it happen? Is there even a remote chance? Well, imagine the following scenario. There's this virus, super virus, that wipes out the human race. For some reason, you and Chris Hemsworth are immune to this. You're the only two human beings on the earth who are left who are immune to this. And you guys are wandering and roaming the world looking for a companion. Is anyone hear me out there? And you happen to stumble across each other, and the lights go on, the music plays in the background. Oh, Chris! Oh, you, whoever you are, right? There you go. So it's possible for you to have a date with Chris Hemsworth, however remotely implausible it is. How does that map here to what I got in the truth table? That was a good example, or maybe not a good example. But how does it have any relevance here? Well, here's the relevance. On the left side, in our simple homely truth table, we have all possible. scenarios in the world could occur. True, 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 false, false, true, true, false. That's like saying, in all possible scenarios in the actual world, here's what could happen. There's this one remote scenario where there's a virus that wipes out the world, except for you two, right? This is a smaller version of that, and you're saying no matter what happens, it's true. So TT possible means no matter what happens, if there's at least one case, however minuscule, where it's true, then this sentence is possible. It is truth table possible. So TT possible means you need at least one true, maybe more, but at least one to make it true. In this case, it's all true all the time, so it's not only a tautology, it's already TT possible. Yeah, already. So you click on that, TT possible, okay. In your thing, you're going to get tautology and in your TT possible, you click assessment, this to verify, you get everything checking out, and then now you save this as table 4.4. You're going to do the same for 4.5 and 4.6. Make sure you find not just whether it's a tautology or not, but also whether it's TT possible. If you think about it, what's the opposite of TT possible? What's the opposite of possibility? Impossibility. So if something is TT impossible, that means there isn't even one true. That means it could never happen. That means it's false. That means alright, that's it for this lecture. We'll practice more in the next one. A lot of this stuff is just mechanical. You just gotta practice, get familiar with it. See you next time.